All right, so I'll be going through question 1B, 1C, question 3A, and 3B of the logs and indices worksheet. I'll try to provide a short and simple explanation of each question as we go. So let's look at question 1B first. So to begin with, we see 4 plus e half x equals to 2ex minus 4 whole thing to the power of half. Now, immediately from this question itself, I can deduce that there's two different types of powers we're looking at right now, half x and x. So probably the best method in my mind right now, I'm thinking would be substitution and forming a quadratic equation between them solve. So let's just try it out now. So we have 4 plus e half x equals to 2ex minus 4 to the power of half. So we can't do anything to the right-hand side. So the only way to get rid of the power half would be to square both sides. So we have 4 plus e half x to the power of 2 equals to 2ex minus 4. Now, as you know, the square expression is a squared plus 2ab plus b squared. So we have 16 plus 2 times 4, 8 e half x. E half x to the power of 2 is just plus ex equals to 2ex minus 4. So we're starting to see a semblance of a quadratic equation. Now we want to move everything over to the right-hand side. So if 0 equals to 2ex minus ex, which is ex, minus 8e half x minus 20. All right, now we want to let e half x be y. This is because when we square e half x, using your indices rules, you get ex. So we take the square of it, and we actually get 0 equals to y squared minus 8y minus 20, which can then be factorized to y minus 10, y plus 2. So now if we move this over here, we have e half x equals to 10, and e half x equals to minus 2. Now, if we understand the behavior of the function e to the power of half x, we will notice it will be somewhat like this, where it will never touch the x-axis and only be fully positive. As such, a negative value of e half x is not possible. Now, moving back on to e half x, we take the natural ln of both sides to get ln e half x to the power of ln equals to ln 10. We use the power rule for logarithms to bring the half x down, and we divide the other side by ln e. Now, ln e in this case equals to 1. So x equals to 2 times ln 10, because ln 10 divided by 1 is just ln 10 times 2. And x equals to, therefore, approximately 4.613 SF. All right, so looking back at the full equation, what we've done was a substitution and a quadratic factorization before solving it using the natural logarithms. So this would commonly be the most common flow of a indices, logarithms, crossover kind of question. And you can tell it's definitely worth a lot by 5 marks. So let's move on to question 1C, which involves logarithms right from the start. So we have 3 log x to the power of x 16 minus 4 equals to log 2x to the power of 5. So immediately I can probably assume that this kind of question will involve the change of bases for logs, which is log AB equals to log CB over log CA. So we always say big one goes on top, small one goes below. All right, so we move back to the question itself. If there's a change of base involved, and given that there's a 2x and x, my guess would probably be that once again, we have to do some kind of substitution. So we must use our log rules as well as some form of substitution to form a quadratic equation. All right, so let's try and do that. So immediately we can see that 3 log x is 2 to the power of 4. 16 equals to 2 power of 4. If we can use our power rule, we can actually bring the 4 in front, but we'll do that later. And same thing, we can use the power rule to bring the 5 down. For just a quick recap, a power rule will be log AB to the power of 5 equals to 5 log AB, something like that. So once again, 3 times 4 is 12. So we have log x2 minus 4 equals to 5 log 2x. So what should we do next is we want to change the log x2 into a log base 2. We can do that using the change of base law, which I've covered up here. So to do that will be 12 times log, big one goes on top, small one goes below, minus 4 equals to 5 log 2x. So log 2, same as log AA, will always equal to 1. So we have 12 over log 2x minus 4 equals to 5 log 2x. Now, we start to see the semblance of a quadratic equation. So we say, let's log 2x be y. So we have 12. 12 over y minus 4 equals to 5y. Times y throughout the equation, we get 12 minus 4y equals to 5y squared. Bring all to the right-hand side. And then we can factorize this. We factorize this to get 5y minus 6, y plus 2. And we must remember, what did we substitute in at the start? We substituted in y as log 2x. So log 2x equals to 6 over 5 and log 2x equals to minus 2. Do not say this answer is not applicable because the base is not, it does not affect whether the negative sign does not affect whether this log is possible or not. Anyway, moving back. X equals to 2 to the power of 6 over 5, x equals to 2 to the power of minus 2, x equals to 0.25, x equals to about 2.30, 3SF once again. So let's review this entire question as a whole and see what concepts are being tested. So from the beginning, we're seeing the power rule being involved in this part here. We are seeing the power rule involved in this part here. We are seeing the change of base being involved in this part here. And we are seeing substitution of a y value into this kind of equation to form a quadratic equation. This concept itself being tested here before finally using into our quadratic equation here, and a substitution in and unlearning the equation so-called. All right, so moving on to question 3 now. Question 3 is a bit more straightforward and simpler. So once again, we start to see some trends in these questions here. So in this case, you see different powers. Here you also see different powers. So we see 2x and 3x. So this would suggest to me sometimes that perhaps a substitution of 3x as y would be the most appropriate thing to do. So this, we must recap some of our indices formulas here. So 3 2x plus 1 plus 3x equals to 2. We must use our indices formula where, you know, x to the power of a times x to the power of b equals to xa plus b. All right, so we want to create this into 2x times 3 plus 3x equals to 2. So here's where the substitution comes in. Let 3x be y. So we have y squared times 3 plus y equals to 2. Bring everything over to the left-hand side. So we have a 0. All right. And then we can factorize this equation right here. We get 3y minus 2. And we get y plus 1 equals to 0. So 3x equals to 2/3 or 3x equals to minus 1. Once again, we go back to how exponentials behave. An exponential function never touches the x-axis, so it will never be a negative value. As such, 3x equal to minus 1 simply is not applicable. So let's move over. 3x equals to 2/3. We must take the natural ln of both sides. So we get ln 3 to the power of x, and we bring that power down like this, equals to ln 2/3. So x equals to ln 2/3 over ln 3, which gives us about minus 0.369. So if we think about it like that, in case you didn't see it, it's ln 3 to the power of x equals to x ln 3. This once again is testing the power rule for your logarithm. So indeed, you frequently see these rules of indices and logarithms being applied to these kind of questions. Once again, the same concept of substituting in to find a quadratic equation being used again. And this question is only worth 4 marks, and it's definitely a way to score because we can start to see the patterns. Now, question 3b is definitely a more interesting question because it may seem like it's trying to trick you into using a power rule in that log 2x squared, sorry for that, is equal to log 2x. Simply, it's not true. All right. Actually, this is not true, and we shouldn't fall for the trick. Instead, what we want to look is for something familiar between these two. So 8 and 2 are the bases for these equations, and actually 8 is 2 to the power of 3. So definitely something can be done involving changing the bases to get something more useful, perhaps. Okay, so let's start working on that. Okay, so another very interesting to take note of is this, that it's actually log 2x and not log x. So something has to be done with that. So we're really going to have to delve into the log rules right here. So let's break it down. So we got log 8 2x equals to log 2x whole thing squared. So let's slowly take it approach by approach. Log 8 2x is actually log 8 2 times x. 2 times x. So we can actually break it into log 8 2 plus log 8x. This will be using your log addition rules. And we keep the right-hand side as it is. Okay, so now what we want to do is change the base to log 2. That will be advantageous to us because then we can see a similarity and perhaps form a quadratic equation with log 2x. So we have log 2 over log 2(8) plus log 2x over log 2(8). Remember, big one goes on top, small one goes below, equals to log 2x squared. Now log 2 same as log 8a, same as log 4 we saw just now, will be just 1. Log 2(8). Now I'm just going to move this over to the side here and just show you a little thing. Log 2(8) is actually log 2 to the power of 3. Power rule, bring it down. 3 log 2, which is just 3, which means this is 1 over 3 plus log 2x over log 2(8), which same thing is 3, equals to log 2x squared. Now we can start to see some semblance of a quadratic equation in the fact that log 2x is a squared value. So we do something similar to the questions just now, which is a substitution. We say let log 2x be y. So 1/3 plus y over 3 equals to y squared times equation throughout by 3. So we have 1 plus y equals to 3y squared. 3y squared minus y minus 1 equals to 0. We want to punch that into our calculator. Because this answer is not easily factorizable, so therefore we must do some gymnastics with it. If you punch into your calculator, you'll get these values. Y equals to 0.767 or y equals to minus 0.434. So log 2x equals to 0.767, log 2x equals to minus 0.434. X equals to 2 to the power of 0.67, which is about 1.70, and x equals to 2 to the power of minus 0.434 equals to 0.74. All right, so if you're interested in how we got these specific values, I actually use the calculator to find them. But if you want to be a little bit more professional and show more kung fu in your style, you can do y equals to minus b plus minus b squared minus 4ac over 2 to get your answer using the quadratic formula. You get definitely a more accurate answer, which you can definitely substitute back in to get a closer value. But regardless, I don't think that's the most important part of the question. The most important part of the question is identifying at the beginning that this cannot be done. Once you have identified that this error cannot be done, then we can move on to start doing the substitution. So we can see the techniques used being here as the change in base. In this case here, there's definitely a change in base involved. Log addition rule. To some extent, if you think about it, the log power rule here. This part involves the log power rule. And once again, we go back to substitution. So the common thread between all these questions, which I have chosen to record for this video, is the substitution technique. So we can begin to see some common themes in these kind of questions about how or when we should use y equals to e half x, or y equals to log 2x, or y equals to a certain kind of value in these questions. And that definitely provides a much more better advantage so that you don't waste time going about different methods. So these kind of questions are common themes you can see throughout log questions, and it's one approach. There'll be other videos about other approaches in the same playlist. So thank you for your time, and thank you.